welcome to the season 9. At this part we're going to talk about some of the commands that creates curves by the interactions between objects. But what does it mean? Let's see. Here are the commands that we're going to talk about. Can be found in curve tools, and then right here let me open the list, which is curve from object tools or commands, which enables you to create curves from objects. And by this toolbar you can create a spaced series of planar curves and points through objects. So let us check them out. The first one is object intersection. Intersect command creates points, objects, or curves at the intersection of at least two curves and surfaces. Object intersection, then we should specify the objects to intersect. For example, I click and drag and then I select these objects and then press down enter. Here as you can see, it has created a curve or point object at the intersection of the two objects. Let me give you another example. You can create the points in just one step. It does not have a specific option in command line. I extrude the curve. Right now we got a surface and then another curve, and then I extrude it by gumball. As you can see, we got the intersection between these two surfaces, and then object intersection, I select these two surfaces and then press down enter, so that we got this curve. Or for instance, let me delete this one, the surface, and then I keep the curve. Right now here, if I specify these two objects, I mean the curve and the surface, as the object intersection, what will be the result? Exactly, we will be given a point. Check this out. I mean the intersection between a curve and a surface is a point, as you can see. I got a question for you. Can we have the intersections between the curves? For example, got a set of curves and then we want to apply object intersection upon these. Here as you can see, it has created the points objects at the intersection between the two curves. So this was all about object intersection command that you can operate it upon two solid objects or curves or polysurfaces. The result will be a point or a curve. At the intersection between curve to curve was point, but the intersection between the polysurfaces was a curve. I delete these. Then in the continuation, I want to create a solid object or a polysurface. Watch this. Here we got two sine shape curves. One more. Check this out. Somehow it is something like topography. And let me move them. Position them at different locations by this way. Copy. Then I want to loft them to create a surface. Check it out. Okay. Well done. So guys, we're done with the surface. Then suppose that we got 2 points on this surface. For example, on this topography, we got 2 points and a specific point, for instance, right there. Check it out, like a villa or a house or whatever. And another region, for instance, right there. I specify it. I move it upwards. Check this out. Then in the continuation, we want to draw a path between these two buildings, and we want to have the shortest path between these two buildings on the topography, which is geodesic curve. However, we call it as short path as well. If I click on it to start the command, then we should select surface for creating a short curve, 2 points on the surface. Then the start of the curve or the start point on the surface, for example from there, and then the end of the curve, which is the another building, for instance. Check this out. Well done. Then we will be given the shortest path between these two objects or points on the surface. Let us try again. I move them or relocate them. Well done. Geodesic curve. Then I select the surface Check it out, and then I should select the start of the curve. We're specifying the end of the curve. Well done. Here, as you can see, we are given the shortest path between these two objects or points. So this is the shortest possible curve between the two specified points on the surface. However, by using the command of offset curve on surface, convert this to a path for the road. So I type offset curve on surface. Check this out. And if you're not familiar with it, don't worry, it's not that much complicated. I'm gonna teach you right now. At first we select the curve on surface and then the base surface. Following that, the offset distance. Even we can flip the directions, as you can see, and we will have the offset exactly on the specified surface. You can use through points or even import the value of the distance, and you can flip the direction. Check this out, like this way. For example, 2, and then enter. Check this out. Let us try again. I select the curve and then the surface, and then this time I flip the direction. 2, check this out. Another offset at the opposite direction. And if I delete the middle curve, watch this. Here we got a road between these two objects. Then I can split these and then assign them to a new layer like this way, like a ribbon. Well done. And in order to have a review upon offset curve on surface command, I'm going to give you another example. Actually, the geodesic curve is not oftenly used, but offset curve on surface is more oftenly used than the short path. Here we got a surface like this by loft, and then by this way. Then in the continuation, by using interpolate curve on surface, that you can draw a curve on your surface, the surface to draw the curve on, and then you can start drawing your interpolate curve like this way. Here it is. Well done. Then I offset it on the surface by using offset curve on surface. Then I select the curve on surface. Here it is, the base surface, or the surface that the curve is placed on, and then the offset distance. Even you can specify the number of the offsets. For example, 3 at this direction, and the offset distance 1.5. Check this out. We got 3 offset curves. I select the origin point, the input, flip the direction, and then offset it. Watch this. At the opposite direction. Well done. What about the point related to offset curve on surface? Let me draw another one to tell you the point. For instance, this one, we got this curve which is not extended to the edges. When the curve is not extended to the edges and when we offset it, check it out, the offset curves are extended to the edges. As you can see, again at the opposite direction, as you can see, they are extended to the edges. So put this point into consideration. And the next command is silhouette. And silhouette create outline curves from a surface or polysurface. Let me give you an example. Here it is, silhouette. This silhouette command creates outline curves from a selected surface, extrusion or polysurface object according to the specified view. For example, here is our view. Then I start silhouette. Then I click on the surface, press down enter. Watch this. As you can see, we are given the curve. Here is the outline curve, and the silhouette direction is based on the current view. So it is totally dependent to the current view. Let me give you another example. At a different view, silhouette, then I select, check this out, a different outline curve. We will be given the outline curve from the very current view. Check this out. The outline curve from the selected surface. For instance, watch this. When you're looking at this surface from the current view, look, we will be given the exact or the very curves that we are observing at the specified view. And the angle of the viewport in the view is very important. And it got only one option. Let me try again, which is about the curves which are placed inside the polysurfaces, like this one. Here, Boolean difference, and then I subtract it. Here is the given result, and then, for example, at this current view, silhouette, the option is internal edges, which has been set to yes. I select the surface, and then let's check it out. Here is the result, as you can see, and if I set it to no, then this will be the result. But if you set it to yes, you will be given the internal edges as well, as I showed you in the previous example. But the next command is very important and oftenly used. For instance, in Rhino, I draw a curve and then I want to revolve it, fully circular. Check it out. Following that, I want to give you some examples upon these revolve. Create a copy. Here we got a curved surface. I revolve these. I rotate this at 180 degrees. Check this out. Then at the top view, I draw a curve like this way. By this way, wireframe to observe it, and I make a copy. So we got it at both surfaces. I move it upwards, and the another one as well, move it upwards. Then here the command that I wanna introduce is project curves. Project curves creates curves or points on a surface that are the intersections of the surface and curves or points projected toward the construction plane. In the continuation, let us consider the function. I modify the layers so that you can compare the curve with the projected curve. Let's see. When we start project curves, it projected the curves on the specified surface perpendicular to the construction plane without scaling the curve. In other words, the project command creates curves or points on a surface that are the intersections of the surface and curves or points projected toward the construction plane. So the current view does matter, and it would be perpendicular to the construction plane, and it does not scale the curve without changing the size. Let's check it out. I select the curve, then I should select the surface to project onto. So right now, as you can see, the construction plane is on the ground, so we will have the curve projected along the Z direction. Check this out. It is projected on the surface, and if we look at them from the top view, as you can see, they are matched. Let me check it out from the top view. Even we cannot recognize the existing of the another curve, since the two curves are overlapping and they are equal to each other. So this is what project does. And the another one, let us try. Select the curve and then selecting the surface and then pressing down enter. Watch this, it projects the curve exactly on the surface. Let us consider the options. Project. I select the curve and then the surface. Well done. The first one is loose, which has been set to no. It projects edit points toward the construction plane onto the surface. When you set it to yes, you let Rhino to add the required control points. Let me try again. Specify enter, and then it projects edit points toward the construction plane onto the surface. I select the curve and then enter. Here is loose, which has been set to no, as I explained it for you before. Here, when we set loose to no, it means that we'll let the curve to add the required control points or to project the editing points to the curve on surface. So here I select the surface, enter. Here is the input curve that got a few control or editing points, but when it wants to be projected on the surface, it needs more editing points. Check this out. As you can see, the number of the editing points or control points are more than the input curve, and this is all because that we have set loose to no. But if we set loose to yes, the editing points won't be added to the projected curve on surface. Yes, enter. And as you can see, here is the result, the final result of the projected curve on the surface. Since the editing points are not added, the curve is not totally matched with the surface. So if you don't have any limitations, you'd better to set loose to no. Well done. Delete input, that if you set it to yes, it deletes the inputs or the curve, and the output layer specifies the layer for the results of the command. If you set it to current, it places the result on the current or default layer. If you set it to input, then it places the results on the same layer as the input curve, and if you set it to target object, it places the results on the same layer as the target surface, which is not that much complicated. I set it to current, and here we get the direction which has been set to C-plane Z. I mean the default value here is C-plane Z, which is perpendicular to the construction plane. However, we can modify the direction. For example, if you click on custom, then you can specify the direction yourself. At the front view, I select the surface, enter, and then I specify the first direction and second direction point for the direction of the projection. Check this out. But we usually use C-plane Z. Let me try again. Select, enter, and then the direction C-plane Z. That you can specify it or customize it actually. I select the surface, enter, then at the front view, and then draw a curve like this. Watch this. So they are not overlapping on the top view, as you can see. But what does it mean? I mean, what does C-plane Z mean? Let me give you an example here. Suppose that I'm gonna create a surface like this, and then I extrude the curve. Check this out by going bold. Following that, at the top view, I pick curve on surface, and then actually not on surface, I draw this ellipse, and then I rotate it like this way. Well done. Position it on there. Check this out. Then let us compare them by this way. I click on project, I select the curve, I set direction to C-plane Z or perpendicular to the construction plane. Then I specify the curve and the surface. Here is the result. Then at the right view, look. Then I want to move the curve downwards to place it on the curve on the surface, and then project. The direction is set to C-plane Z or along Z-axis. I specify the curve on the surface, press down enter. Let's check it out. As you can see, the curve is projected based on the current view, but the other one is projected based on the top view or the perspective view. So the current view does matter when you want to project your curve on your surface. And the next command is pull curve, as you can see. And as you can see, the icon of the pull curve is very similar to project, and functionally it is somehow similar to project. However, it has some differences. I specify the curve, enter, then I should specify the surface that pull. I click on the surface, then enter. Check this out. Here, as you can see, the pull command creates curves and points on a surface that are at the intersections of curve or points pulled toward the surface in the surface normal direction, and it has minimized. In other words, the curve has pulled toward the surface in the surface normal direction, not Z direction. I mean, well, we use project, the curves projected toward the construction plane, but right now they are pulled toward the surface normal direction, and this is the difference. So the curve is exactly perpendicular to the surface I want to try again and then explain more. And then the surface. Check this out. Here, as you can see, the curve after being pulled is minimized. And then at the next example, as you can see, the curve is pulled toward the surface and it is maximized after being pulled toward the surface. And then if I move the curve downwards like this way, check this out. Here I select the surface and then enter. Check this out. But how the curve is perpendicular to the surface, to the target surface I mean. Here we got a curve which is normal to surface. I mean it draws a curve which is perpendicular to the surface. I select the surface and then if I specify a point and then draw the curve, check this out. It is normal to the surface. Or for example another point, check it out. Right now these curves are normal to the surface or perpendicular to the surface. Or let us check this. For instance, from this point, check this out, another curve which is normal to the surface. One more, check it out. So these curves are normal to the surface, not to the construction plane. So when we are using pull command, the continuity of the surfaces do matter, and the size of the curve after being pulled toward the surface will be changed. And here I want to introduce one of the applications of pull in the following example. For instance, we got a surface like this. Check this out. I want to create a wall like this way. Loft, and then create the surface by this way. Following that, at the front view, by using project. Check this out, this curve. Following that, I start project command. Then when I want to project the curve on the surface, can I project it at the perspective view according to the explanations? I mean, I want to project the curve on the surface. Can I choose the perspective or top view for the projection? Let's check it out. Absolutely not. Since our construction plane, as you can see, is on the ground, and in project, the projection is normal to the construction plane, while if you want to project the curve on the surface, you should open the right view and then project the curve on your surface. Watch this. So the current view that you specify for the projection does matter. In general, we project the curve on the surface and then we may want to rebuild the surface, and as you're concerned, when we rebuild the surface, we can simplify the curves, so we will have some changes. And here, as you can see, the surface is not matched with these curves. After rebuilding the surface, I move them to check them out. Watch this. As you can see, the curve and the surface are not matched with each other. So by using pull command to pull the curves and points toward a surface in the surface normal direction, so that we can fix these parts because the curve is normal to the surface direction. So that here we can start the command of pull, and then we select the curve in the perspective view. Following that, we specify the surface, target surface, and then enter. And since the curve is pulled toward a surface in the surface normal direction, the current view does not matter. While in project, the curve will be projected normal to the construction plane, so the current view do matter. I mean, the current view is important in the project actually. Let me show you again. Pull. I select the curve, enter, and then I recommend you set tilt input to yes, since we just need the results, not the input. And then I click on the surface, press down, enter. Check this out. It is pulled toward the surface, normal to the surface direction, and as you can see, the curve is pulled toward the surface. And note that when you are using pull command, the current view has got no effect, since at any condition it is normal to the surface direction, while it was effective in the command of project. Here I want to give you another example at the another surface, and then we're going to finish the session. And then talking about other commands at this season. So pull curve, and then I specify the curve, then I click on the surface, enter. Check this out, it is pulled toward the surface in the surface normal direction. So guys, as usual, it's your turn actually to practice the given lessons.